In this lesson, we're going to explore the structure of the atom and the concept of isotopes. By the end of the session, you'll be able to identify the main components of an atom, what makes up the smallest unit of matter, explain the meaning of isotopes, which are atoms of the same element that differ slightly in their composition, and finally, distinguish between an atom and an ion, since ions are key to understanding how matter behaves. Let's begin with the concept of the atom. An atom is the smallest particle of an element that still keeps the properties of that element. To imagine its size, if you lined up about 100 million atoms in a straight line, they would stretch just 1 centimeter. Every sample of an element, like gold or oxygen, is made up of identical atoms, and the atoms of one element are completely different from those of another. For example, hydrogen is not the same as carbon or oxygen. Atoms are not indivisible. They have an internal structure made of smaller particles called subatomic particles. There are 3 main subatomic particles: electrons, protons, and neutrons. Protons and neutrons are about 2,000 times heavier than electrons. The electron carries a negative charge. The proton carries a positive charge, equal in size but opposite in sign. And the neutron has no charge. It's neutral. So an atom is composed of positively charged protons, neutral neutrons, and negatively charged electrons. Now, how the subatomic particles are arranged in an atom. All protons and neutrons are found at the center of the atom in a tiny region called the nucleus. The nucleus is extremely dense and positively charged because of the protons it contains. Almost all the mass of an atom, over 99.9%, is concentrated in the nucleus. The electrons move rapidly around the nucleus, forming what we call the electron cloud, which determines the atom's overall size. Let's try to answer this question together. The diameter of an atom is about 20,000 times larger than the diameter of its nucleus. To visualize this, imagine the nucleus being the size of a basketball, around 24 centimeters wide.
So, what would the diameter of the atom be in this case?
Before continuing, pause the video and take a moment to solve it yourself. Then check your answer. If the nucleus were that size, the entire atom would be about 4.8 kilometers across. This means that most of an atom is actually empty space. Every atom is identified by 2 numbers, the atomic number and the mass number. The atomic number, noted as Z, is the number of protons in the nucleus. It determines which element the atom belongs to. The mass number, noted as A, is the total number of protons and neutrons. We can calculate it as A equals Z plus the number of neutrons. For example, a nitrogen atom with 7 protons and 7 neutrons has a mass number of 14. Isotopes are atoms that have the same number of protons but different numbers of neutrons. For example, boron exists naturally as 2 stable isotopes: boron 10 with 5 protons and 5 neutrons, and boron 11 with 5 protons and 6 neutrons. Their natural abundances are 19.9% for boron 10 and 80.1% for boron 11. Isotopes are represented using nuclide notation. In this format, the mass number is written at the top left and the atomic number at the bottom left of the element symbol. For example, carbon-12 is written as 12 over 6 C, meaning 6 protons and a mass number of 12. In the periodic table, elements are arranged by increasing atomic number. Each box shows the symbol, atomic number, and atomic mass. The atomic mass often includes decimals, like 10.811 for boron, because it represents the average mass of all naturally occurring isotopes, weighted by their abundance. Let's calculate one together. Carbon has two isotopes, carbon-12, which makes up 98.9%, and carbon-13, which makes up 1.1%. Multiply 0.989 by 12.00, then add 0.011 times 13.0034. The result is 12.01 atomic mass units, very close to carbon-12, the most abundant isotope. An ion is an atom or molecule that has gained or lost one or more electrons, giving it a charge. There are two types. A cation is formed when an atom loses electrons. For example, sodium becomes sodium plus, written as Na+. An anion is formed when an atom gains electrons. For example, chlorine becomes chloride, written as Cl-. This process is crucial in chemical reactions and compound formation. Now let's apply what we've learned to these atoms. Remember, pause the video and complete the table before checking your answer. Chromium-53 has 24 protons, 29 neutrons, and 24 electrons. The total number of subatomic particles is simply the sum of all three. Keep in mind, ions differ from neutral atoms mainly in their number of electrons, as we observe with magnesium and bromine. To summarize, each atom of an element contains the same number of protons. That's the atomic number. Atoms of the same element that differ in the number of neutrons are called isotopes. A neutral atom always has equal numbers of protons and electrons. When electrons are gained or lost, the atom becomes an ion, carrying a charge. These ideas form the foundation of chemistry, helping us understand how matter is built, how it reacts, and how everything is connected through atomic structure.